Hello, my name is Sophie Yu. I'm a Greenwich High School sophomore, and my project is to make a machine learning model that can segment pediatric brain tumors from multimodality MRI scans. Brain cancer is often treated through radiotherapy or surgery, both of which require a precise segmentation of the tumor, often drawn by physicians. This process can be time-consuming and subjective when done by human hands. Brain tumor segmentation is a highly researched topic, but many train their models solely on adult data. Not only do adults and pediatric brains have structural differences, tumors tend to be in different areas of the brain, and tumors tend to grow more aggressively in adults. These differences will require a separate pediatric data model. The BRATS Pediatric 2024 dataset had 266 patients, each with 4 MRI modalities: T1, T1 contrast, T2, and FLAIR. And along with the ground truth segmentation of the tumor, which had the enhancing tumor, the non-enhancing tumor, the cystic components, and the edema. There seems to be a label imbalance, with the tumors primarily being non-enhancing and cystic components and edema appearing in only a few patients. At first, plain classic UNet was used. There was pre-processing that changed NIfty files to HTF5 files. However, the targeted ending model did not reach the targeted accuracy. Another attempt or idea was to use atomic that could segment adult brains, except the dataset that was used was the BRATS 2023, which had different labels than the BRATS 2024 pediatric dataset, so they could not be compatible. During training, the local computer's GPU often ran out of memory and killed the processes. So, a remote GPU server was employed using prime and select. Finally, NNUNet, a self-configuring model based on UNet architecture, was used. The difference between NNUNet and UNet is minimal, except there are optimal parameters chosen for UNet and NNUNet, and also optimal preprocessing applied to the datasets. In addition, a specific folder structure was required for NNUNet, so here's the code that was used to change the file structures. However, in remote GPU services, this code was uploaded and run over there. The first model trained on NNUNet suffered from severe overfitting, so more training data was used, and the final split became 188, 45, and 27 for training, testing, and validation. To calculate the whole tumor dice score, NIfty images from inferences were taken and sent up by arrays, and all non-zero values were set to 1. Then the ground image segmentation and the inference segmentation were calculated with dice. It came to be 96.348%.